shortly. I'm not sure why I put this in the lecture now. It's actually will be more useful later in the course, but I'll mention it now. In modern web browsers, there is a debugging option called the console window, as well as a bunch of other developer tools that we may or may not get to. But you can see code running and look for errors when you're debugging. This will be very handy with the JavaScript API. In Chrome, and I think it's in all Chrome, Firefox, and IE now, if I'm not mistaken, you can hit F12 to get access to this console. But if you do that and the site's already up, you have to hit F5 to refresh again. You can also write output with console. So if I go to Chrome, and hit F12, it brings up this console, and you can look at some of the things here. Show you which style sheets are in effect. That's beyond where we're going to get here, but see, it shows the body style sheets that are used by the Google website. There's a lot of other things you can do on here beyond what we'll get into. But here, for example, are the style sheets that are used to render the CNN page. We talked about style sheets at the end of wasn't last week, it was 2 days ago. This, and some of this even over my head, this tells you you can kind of track how long it takes to load every element on the page with this network. So whatever this is took the longest. The weather page took 550 milliseconds. You can't see that to load. 383 of the milliseconds were for this particular item. And then you can see it in code. Again, beyond, I'm showing you what kind of things a network engineer would use these things to trace why a website is slow or maybe stuck on something beyond what we would do here, but I want you to kind of just be aware of these things. You can look at like the source CSS files in this console. So that's kind of cool. So these are all the CSS files that are used to define the weather page. For example, they have a class called forecast section where they've defined styles for what the area where they give the weather forecast looks like. And I click this to go down here, but the main thing that we're interested in is this console. The console will monitor traffic, and I'm going to go now. I'll click on Buffalo to get the weather forecast. Oh, and we're not getting any warnings. Let's see. If there were errors, they would appear. Okay, so now the Esri, I knew I could rely on Esri. The Esri page caused an error that you wouldn't normally see. So I've gone up. This is the ArcGIS Online page. Did you get an invitation? Okay, good. I think I have to add you to the class group next, which I'll try to remember to do. So here, there's, and I admit I'm not quite sure what the error is, but there is a couple errors and warnings on Esri's website. For example, they have an event property position where they should be using loading. So this comes in handy when you're debugging your website. These consoles. Okay, I'll add you guys into. I'll do that tonight. Add you into the group. We're not going to get into this till next week, but I created a group in the ArcGIS Online account for this class. But more importantly is this console. And I'll open up IE. Hit F12. Internet Explorer, it looks a little different, but Internet Explorer has the same things. So there's some warnings and error messages on the msn.com site, and you can see them. That's my license server. You can see them on the console. And then finally, Firefox. That's weird. I've had trouble with Firefox. It may not open. It is good practice as you become a web developer. You often have to test your site. Don't assume that your site will work the same in every browser. I mean, you'll need to test your site in Firefox, Internet Explorer, Chrome, and probably Safari. And like I said last week, I'm not even mentioning these at that point. F12, yep. It's the same F12 in Mozilla and brings up the console.
So when you pull up Google Chrome and in Google Chrome, you just hit F12 and you look at the...
Yes. Yeah. And that also goes for Firefox, Internet Explorer, or whatever it's called, the Edge.
So this pane here is called
the console, or it's the developer. Each one has a different name for it, like the developer window. But each one now this has the shortcut of F12. Some are better than others. I've actually sometimes Firefox has the most robust debugging. Firefox was the first browser, I believe, to really offer these things, and the other browsers have been catching up. So in Firefox you can do more things like limit just to a .NET error, just show style sheet errors, and things like that, just social security errors here. Like you can choose whether or not to show a JavaScript error or not. So that'll be more prevalent later in the course, but it's in the slides now. And yeah, in each of the browsers, and I don't have Safari installed, but I think it's F12 also. It's not that easy to do that on an Apple tablet. Honestly, I don't remember the workaround, but it's not pretty. You have to slave the Apple tablet to a machine, like a laptop somehow, to see errors. And to be honest, I don't remember how to do that. Luckily, I haven't had to recently. So I guess I showed all three. So there's Chrome. Here's a screenshot of Firefox and a screenshot of Internet Explorer. I did this in IE10, but I think IE11 looks like it has the same functionality. IE11, I think now is actually called the Edge. They're trying to unbrand. Internet Explorer is not very popular, so I think they're trying to brand it as something different. Sometimes you get lucky. When we work for the federal government, often they can only use Internet Explorer. Like when we do a site for the Army, they're not allowed to use Chrome and they're not allowed to use Firefox. So I think that's changing, but that makes our life easier because then it only has to work in IE. Any questions? So we will talk about JavaScript now. JavaScript is a main component of this course, something you'll use a lot, and we'll then build onto this and learn the ArcGIS JavaScript API later in the month. What is JavaScript? It's the most commonly used scripting language. It's a lightweight client-side scripting language, so you program JavaScript scripts run on the client, on the user's machine, not at the server. It adds interactivity to web pages. It It works with HTML and has been used on billions of websites. This is, like I think I said at the onset, this amazes me that this is still relevant. I learned it in 1998, and I think every single other thing I learned in 1998 is long gone. But JavaScript remains. And it remains because it's simple, it's easy, it's lightweight, and it works on all modern browsers and mobile devices, tablet devices. What really brought it back is, these things don't support Flash or Silverlight, but they do support JavaScript. So I'm amazed that I'm still talking about this so many years later. JavaScript's been around a long time, since the advent of the World Wide Web in the 90s. And it's not going away for those reasons. And it's this widespread compatibility is why it's so important. So we did, this slide is somewhat of a review. Last week and Monday and last week we created a new HTML page. You saw me do that. And I think I briefly did this at the end of last week just to intro it, but to give more detail. Here's how you could add JavaScript to an HTML page. We'll see later, especially in the ArcGIS Server API, you can reference JavaScript functions from an external JavaScript file, just like we referenced external style sheets from a different CSS file. We can do the same from a different JS file, and JS would stand for JavaScript. For now, we'll keep it easier, and we'll put the JavaScript right in this HTML page. And we do that with a script tag. Use a script tag somewhere within the body. You start it with script, end with /script, and the attribute is type equals text /JavaScript, as I wrote here. And then everything within the code is your JavaScript. We'll see shortly how you can write specific functions. You can have specific functions, or you can just add code, and any code that's not in a function will just run when the page loads. You'll notice a lot of similarities, those that are proficient in C#. You'll see a lot of similarities between C# and JavaScript. The languages are very similar. JavaScript is easier. I've heard to put this at the bottom so that the content can load before the JavaScript, so the user's not waiting. It's not a steadfast rule, but I've done that just because I've been told that's a best practice, to put all the tags that render the page above the script, so the images and stuff show up first and then the script is loaded. Obviously that may differ in individual cases. Note, just to review from the end of Monday, notice how we have a link here referencing to an external style sheet. At some point, I don't recall if it's tonight or later, we'll see how you can do the same to link to an external JavaScript page. So if I were to go to my site, I think I'm actually going to create a brand new. There's a lot of mess in this. New file, HTML page, June 3rd, A. So there's my script. Type equals text /JavaScript. While we're here, we'll learn our first JavaScript function, alert. Alert with a string as arguments gives us a pop-up message box. So notice this is not in a function. I just put one line in my JavaScript. Like C#, every line in JavaScript ends with a semicolon. Notice that ran. There's the pop-up box. with the message, the alert message. And again, the reason it just ran is because it's not in a function. When the page is loaded, any JavaScript here that is just within the tags will run on page load. So obviously that's a strategy that you'll consider when you're developing. You know, there's things that you might want to run all the time as soon as the page starts, which we just put in here. There's other things you'll want to put into a specific function that are only called at specific instances, which is the next topic.
So as in you would the event would occur after the page is loaded, or something would trigger it.
Exactly. Things that you want to happen after the page reload, that's exactly it. Or from a specific button or something. Yep, you got it. So, there's our first slide. Next slide. Here's an example of a function. You define a function quite easily enough with the keyword function. Lowercase, like C#, JavaScript is case sensitive. So when you see lowercase here, it has to all be lowercase. Visual Studio will recognize function, make it blue. Then you give the function a name. It's somewhat of a customary to name it starting with a lowercase letter and then have additional things in the letters being capital. Like I've done here, you don't have to. That's a practice that many people use. And then a function doesn't have to, but can accept arguments, and the arguments are in parentheses. So whoever's running the function can pass the arguments. A function then is defined as a starting, stopping with the curly brackets. So everything between, and the start of a function doesn't have the semicolon. Everything between the start and stop function is this function called click function. So somewhere for that to run, notice if I say if I preview now, nothing happened. Because the alert is inside the function. This function has never been called. So you have to call it from somewhere if you wanted to do something. And to do that, I'll just throw in something quick. So notice now, let's back up. I wrote a form like we learned about last week. I added an input of the type text where the user can enter into a text box. I gave it the ID. Remember I said this would start to become important? Now we're at the point where the IDs are important. So this text box has the name in code, my text. So I can now refer to it with that keyword throughout my code. I then added a button. Button's called my button. And then I added an event. And on a button, the event is on click. So it says on click equals, and notice it says click me. So now when we click the button, it's calling the function. So now we are utilizing the JavaScript function. And what are we passing? The click me function requires an argument. I'm passing it my text.value. So the button calls the function, but it first grabs the value the person put in the text box, sends that to the function. That becomes in text, and now I'm alerting in text. Whatever that is. So if I type this, it sends that message and alerts it. Whatever the text changes to, it's going to alert that message. So our very first simple example of calling a JavaScript function. It's a good start. It gets much more, when we use JavaScript functions for ArcGIS, it's going to be a little more complicated than this, but we got to start somewhere. So now that we got that out of the way, we'll spend some time talking about fundamentals of JavaScript. Oh, anything?
I noticed when I'm writing the code on like C#, I omit some semicolons, but it still runs successfully.
Really?
So does it mean in HTML or JavaScript you can omit some semicolons?
Probably. Maybe I'm surprised. I think maybe sometimes the semicolons aren't necessary if the statement can still execute. Off the state, what's an example of a semicolon do you remember or you omitted?
Just in every statement, I just omit the semicolon. I want to try if it can work.
And it worked, really? It didn't give you the in C#?
It didn't. And I also Google it, and it said that there is a protocol that in JavaScript there are some semicolons are allowed to be omitted.
I wasn't aware of that. I've always thought in most cases you need them. That's interesting. I'm not sure I would assume then it would be similar, given that. That's interesting. Usually even in Visual Studio and C# it'll give a little error message.
Yes, but in
It doesn't show it. Interesting. We'll try that. JavaScript is a little more, like I was hitting, is a little more flexible than C#. So what that may mean is that JavaScript, if it gets to the end of the line, it's better at realizing it's the end of the line, whereas C# you kind of have to tell it the line is ended. I'll have to try that. I wasn't aware. I always put my semicolon and never tried without it. That's very interesting. So we'll try that a couple times. Some fundamentals of JavaScript. We talked about comments in HTML. If you remember, comments are things in code like we had something like that to comment out HTML code. And things within HTML code, I think that's actually, those were the symbols. All these are comments. And to review what that means is they don't run. So you can remove code by putting comments around it and it'll turn green, or you can add your own remarks in English to kind of indicate what the code is doing. JavaScript has the same thing, but it's 2 forward slashes at the beginning of the line. So you see there, I have a JavaScript statement setting a variable. I've commented out the line with the 2 forward slashes. And Visual Studio will turn green. That line will not run. So I said the two main purposes are to add notes in your code, kind of explaining what it does. That's very helpful for the next person. Once you win the lottery and quit and someone else has to take over your code, you're doing them a favor. And then also, it's used for debugging. Say you can't get your page to work, you may want to remove lines of code to see if it works. If it then works, something in the lines you removed is what's causing the problem. As we talked about at the end of last class, JavaScript is an object-oriented programming language. Object-oriented language, as we said, we talked about the geese and the crows. They store information in variables of a specific object type. But unlike some languages, I mean in C# there's thousands. ArcObjects has 12,000 different classes. JavaScript is not like that. There are very few predefined objects. In many cases, we can declare an object just with var. So in other words, JavaScript is a much less formal language than C#. You can also, and so some types of variables you can set. I think a slide is coming up on this. You can add properties on the fly in JavaScript by just adding another dot. You know, my variable dot winter, and then suddenly now that object will have a property called winter. That's all you have to do. Where in C# you could never do anything like that, because in C# the properties and methods are predefined. But to talk about some of the common variables you would use, a string variable represents a piece of text, a series of characters without any numeric value. So here I'm declaring a variable. You often don't have to declare the variable type. That's another difference from C#. In C# we would have to say that this is a string. Here I say var for variable, give the variable name, equals, and then I'm setting it to something in double quotes. So I'm setting the variable myUniv to be equal to the string University at Buffalo. So again, a string is a variable that has no numeric value. It's just a group of characters. Two fundamental JavaScript methods that will help us as we talk about variables this is similar. C#, there is a variable type of, a keyword type of. So all one word, there's no space. So you can use the keyword type of, give it a variable, and get the type of variable that it is. So here I've declared this variable to be equal to the string UB. On the next line I said alert type of my university and came back and said string. Also, I'm kind of sneaking in the definition for alert, which we looked at a couple minutes ago anyway. Alert is a common way in JavaScript where the programmer can present text information to a user. In C# and other desktop languages, you might be familiar with the message box. In JavaScript, it's an alert. Lowercase, of course. This is somewhat misleading. The headers, both type of and alert, should be all in lowercase. So some other common methods on strings. Length on a string will return the number of characters it has. Pretty simple. And again, all in lowercase. So here I've set the variable my name to my name. Then I'm alerting my name, and again, to get a property, it's dot, and then the property. So the variable dot length in lowercase, in this case, returns the number 13, because there's 13 characters in my name, including the space. Don't forget that a space is a character. Sometimes, I've certainly had to write code like this where we're parsing out user input or parsing out. By parsing out, I mean taking a string that you've gotten from a database or somewhere and extracting just pieces of it. You might get a long string of someone's name and you're just extracting the first name or just extracting certain characters. You can, another example, every property has what's called a PIN number in New York State. It's like a 22-character code, but embedded in that code, there's sections of that number represent what town the parcel is in, what block it's in, what neighborhood, and so on. So you would extract pieces of it. One way you would do that in JavaScript, so these are a little different than C#, is the char at function with the A capital. So So CHAR lowercase, capital A lowercase t, and then a number. And this is 0 based. So when I say it's 0 based, what this basically is doing is asking for the 6th character in the string. So the 6th character of the string is a capital C, because you have GREG space C is the 6th character. The G is character number 0. That's why it seems shifted by 1. The R is character number 1, and so on. So if you have the need, and I'm saying this might seem abstract, but I've certainly done this. If you need to extract the character at a specific position in your string, you can use this char@at function with a capital A. The reverse of that, to some degree, is the index of function with a capital O. Index of takes an argument. Now, char@'s argument was the position you're looking for, a number. Index of's argument is a string, and then it will look through. It'll look through your string for that string. So in this example, I'm saying index of, and then the string I give it is the lowercase o. It will look through my string and find the first occurrence of lowercase o and return the position. So it returns 6, indicating that the lowercase o first occurs as the 7th character. See the difference there? So it's kind of the opposite of char@. In char@, we have the position, we want to know what letter's there. With index of, we want to know where the letter is. If the letter does not occur, the number that will be returned is -1. A -1 returned from index of indicates that there is no character. It also doesn't have to be one character. I could search for Greg, for example. And then what it would return in that case is 0, the start of the string you're searching for. So you don't have to only search for one character. Any questions?
I'm just going back to your string definition here.
Sure.
A string variable represents text.
Yes.
Without a numeric value.
Yes.
And I'm just trying to connect the string with what you just explained.
Okay. So on this slide, hopefully this helps.
Pardon me, what so the role of string plays what
In this,
yeah.
I'm defining a string variable here.
Okay.
So the string variable I've set to my name. And it's a variable. The variable's name is my name. So now the computer will store that value in the variable my name. So now my name becomes this. And so what we're talking about now, we're talking about string variables and different things we could do to a string variable.
Okay.
Does that help a little bit? So,
yeah, and so the string plays what role in the code, in overall?
often you may want to store the person's name for later. Like, for example, you ask a person's name when you sign it. It's a way of storing a piece of text as a variable that you can refer to later.
Okay.
Like in that example I did a few moments ago, the person puts their name in and hit enter, and I assigned it to a variable. So you log into a website, it says what is, you enter your name and password.
Right.
It's storing your name as a string variable for use later.
Okay.
And the difference is, and we'll talk about it's a piece of information without numeric value.
Okay.
Your name doesn't have any numeric value.
Is that equivalent to if they wanted to save the password, save the name, and so when you went to that site, it automatically kind of populates?
Yes.
Okay.
So you're storing it in a variable so you can use it later to populate something or do other things.
Gotcha. Okay.
Does that help? Okay. But then the other key is that it's not numeric.
Okay.
And so when you're defining a string this way, you indicate it with double quotes. And so what we're doing is going through some of the things we can do to a string variable. We have two functions here on top, two lowercase and two uppercase. That do, you probably guessed what they do. But again, it's important that the capitalization is exactly how it's pictured here, starting with a lowercase t, then uppercase, case, and lower and upper. So here, this is the original string variable. This is a little different than the last slide. In the last slide, we're using these functions to get information about the string. Some of these functions actually converts the string into something new. So here, the original variable says, string variable says hello world. To uppercase, and it does need a lot of JavaScript functions need this. There's no argument, but when you see this in the definition, you do need the empty parentheses at the end. That takes the original variable and then makes all of the characters capital, where there's lowercase characters. So if you want to convert your string with letters in it to be all capitalized, you can string dot to uppercase. And obviously to lowercase would do the opposite. Sometimes that's important if you want a user to enter their name and you don't want it to be case sensitive, you could just convert everybody's name to uppercase, so that, say one day you enter Daniel in lowercase and then the next day you do it in uppercase. In the code, after the person enters the name, just switch it all to uppercase and just deal with it as the same. So two lowercase and two uppercase affect the case of the variable. And here, I'm alerting it so it pops up so you can see it on the screen, but you could set this to a new variable. So I'm declaring a new string variable. Instead of alerting it, I could say set it to a different variable. So here, myvar2 is equal to myvar, which is my name, not to uppercase. And if we alert that, notice myvar2 now is the original variable converted to uppercase. Two other conversions, and we'll talk the second one here in the middle, split, can take a string of characters and make it into a list of what we call an array. We'll talk later about a list. But an array is a list of items in it. So split takes one string and then splits it into a list using the string passed in with split as the separator. So I think this example is a good one. If the string is 1-2-3, and I say split, and pass it a dash, the result is an array, which is in a list. We'll talk more about arrays, with a 1 in it, a 2 in it, and a 3 in it. So it'll be an array of 3 objects. To complicate this a little, if that was the original string, you would get 1, 3, 4G. So this character on the split method, that character is what splits the original string. If this character doesn't exist, presumably you would end up with an array with 1 item in it, just the whole thing. Any questions on that?
I noticed that you, for the uppercase, example, you can use var to declare a variable. Does that mean it is a global variable?
Yes, and sometimes because that you don't have to use var always. It's very forgiving. But did I do that here
You didn't write it down
in the example? Yeah, and it still worked. That makes it a global variable, and it's especially with string variable, you often. I'm not sure when you use it. You may rarely need to use var.
I Google it and
Yes.
it said that in the function you may use a var to declare a variable to mean that it is a local variable inside.
Within the function, yeah. So outside the function, it doesn't matter. But that's a good eye and good point. So this makes it a global variable. So var inside the function, you're saying makes it local just to the function.
Make it local in the function.
In the function. Okay, yeah. We'll make sure. That's why we use var. I think more as we get into our JS server JavaScript. There's more local variables that you would use within specific functions. That's where you use var. That's a good point. That it's not necessary. Like it's another thing. Like unlike C#, where it's very forgiving about that. And then, any other questions? To string, sometimes we have a number or another type of object that we want to alert. In alert box, it's one example of why we do this, there might be others, requires a string. We'll come across other methods as we go that require a string. If the variable type is not a string, we convert it with toString. So it's TO capital S string and the parentheses. So here I've set a number. Notice when I define this to 34.5, there's no quotes. So that's a number variable. To convert the number variable to a string, and this is a little bit nuanced. The difference between there's a number variable and this. It looks like the same thing, kind of, doesn't it? The number variable, we could do math on 34.5. We could multiply it by 2, add something to it. The string, this is just the characters 34.5. Sometimes other methods require a string, so you do have to, and we did this in C# a fair amount too. You have to issue toString to convert the number to a string so it'll appear. One example would be alert box. Any questions? Some other things we can do, again, still with strings. You may want to take a string and replace items with another string. I'm trying to think of an example. Maybe you wouldn't do this as often. So on the string variable, in this case greeting, dot replace, and then 2 arguments. We separate the arguments with a comma. The first argument is the item to search for. It's not unlike what you would do in Word or Excel. The second item is what you're replacing it with. So here, take the original string, search for the occurrence of hello, replace it with bonjour, and there's the result. So that's done with the replace method. The search method is similar to, it's fairly similar to index of. I think you can Google on the website. The differences are subtle. The search is similar to index of, where you're searching for a character and it returns the position. So if we're searching for exclamation point in hello world, it returned 11 because that's the 12th character in hello world. The main difference is search lets you work with things called regular expressions, but beyond what we're going to do right now here. The search is more robust for more advanced uses. Index of also lets you start. I didn't show that. I don't use that often. With index of, you don't have to start at the beginning. Let's say you wanted to search for a letter, but only start at the third position and not search the first two letters. You can do that with index of. Both things that are somewhat beyond what we're going to do here. And then slice extracts a piece. It's like slicing a piece of cake out of the pie out of the pie. You pass slice. You use there's two arguments with a start and stop number. That represents the area to slice. So slice 3,7 will take the string variable and extract just the piece of that string variable that starts at the 4th letter and then ends at the 8th letter. So we get LO space W. So we start at the 4th letter, 4, 5, 6, 7. And it returns that. So if you want to pull out a specific subset of a character, use slice on a string variable. String variables in JavaScript, and again, this is like similar to C# in Visual Basic languages use an ampersand. I catch myself doing that. String variables are concatenated with a plus operator. So by concatenation, I mean taking two strings and combining them into one string. So here I'm actually taking 3 strings and combining them with 2 pluses. So there's the variable first name that is equal to Greg. The variable last name is equal to Caniglio. I have another string here that has 2 quotes around it. That's a space. It's just a string with a space in it. So I'm saying take the variable first name, concatenate a space after it, and then concatenate the variable last name. So 3 strings here being concatenated with the plus, and then there's the result. The first name, space, last name. So plus is the concatenation operator in JavaScript. That is something you'll use a lot. Similar to that, this is a regular expression. It's kind of weird. We have the same thing in C# actually. \r\n is a regular expression, a keyword that's the same as a new line. So instead of a space, first name plus \r\n gives you a carriage return within the string. So see now how my name starts on a new line? That's because I use /r/n as a string. That's a regular expression or a keyword that basically starts, everything after that will start on a new line. Any questions so far? Making up time.
This, I'd like to ask them, why do we have different methods of strings?
What?
Why do we have different methods to strings?
Versus, I mean,
Just like why are we going to explain what are we accomplishing with that?
these are all different things that you can do to a string.
Okay.
Like,
Right, but I'm just saying, why are there different methods? Like, what's
to help differentiate, for example, these might be, you may want to extract. So these are all different methods defined on a string for all the different things you might want to do to it or retrieve from it.
okay?
And they're specific to a string, like extracting a number might not make sense. So a lot of these things, not all, some are generic, would be methods that are specific to a string of text.
Gotcha.
And so each one is a little different. So we have, and there's quite a bit more. I'm trying to focus on the things that you use most often.
Gotcha.
But there would be even more than this. Does that help
Yes.
clarify? Yeah. So each one of these does a specific, different operation, either just retrieving information about the string or changing it, as we see in some cases. And we'll actually talk about numbers and some different methods on numbers and things as well. But first, we will talk about if statements. This is our first exposure, and some of this will be redundant for C# people. The slides are very similar for those that have experience with C#. The format and the syntax is very similar to C# on a lot of these, the following content. So an if statement allows us to test if a particular condition is true. If that condition is true, we can then have a certain block of code run, but that code only runs if the condition is true. So here's some generic examples of if statements. So you start out with the keyword if in lowercase, and then you have a parenthesis. Inside the parentheses is our statement. So that statement evaluates the true or false. If high temp, there's a variable high temp less than 68. So either that variable is going to be less than 68 or not. If it is less than 68, code will run. If it isn't, that code won't run. Another example here, exclamation point equal is not equal. So when you see exclamation point equal, that means not equals. So if the graduation year is not 2013, is what we're evaluating there. When we're evaluating strings in JavaScript, we use a double equal sign under this statement. A single equal sign wants to set the variable to that. A double equal sign is used to when we're evaluating a statement. So town name, double equal sign, Alden, we're evaluating. And notice this is a string variable, so it's got the quotes around it. We have not talked about the fourth example yet, but another type of variable is a Boolean. A Boolean variable just has two choices, true or false. So here we're saying if the variable eval results is false, do something. And then finally, we can compare two variables. So earlier in the code, I've defined a variable str1, str2. Here we're just evaluating whether the two variables are the same. And this ties into the next line. So an if statement also has an else statement. It can have an else statement associated with it. So here's our condition, like we saw on the previous slide, in parentheses. After the if statement, we have, you'll see this over and over, the curly brackets. So if that's true, if max temp was less than 68, if the condition turns out to be true, whatever code you type in here will run. If it's not true, it won't. It'll ignore. If that statement is not true, this code will not run.
All right. So, for example, can you give us an example?
I'll type an example in a second, yeah, because I think that's simple, so we would do that. And then else, not every if statement has to have this. It's not necessary. But then you can have an else to make this code run if the statement is false. I'll go over this and then we'll actually program one. So here, I'm prompting the user to enter a temperature. So say the person enters, and notice this is a slight deviation on an alert. The prompt box lets the user type in something. So if we enter 70, user typed 70. So here, if temperature is greater than 85 is the first statement. Well, it's not. 70 is not greater than 85. So this line will never happen. This is a little more advanced. We have an else if. I'll get to that. An else if gives you a third choice. So now it goes to else if. Is temp greater than 32? It is. 70 is greater than 32. So this line will run, and we're done with the loop. Say the user had entered 30. That won't run. That won't run. Else will. Because the else is the fallback, and it'll say it's too cold. Let's type example. So remember, so I'm going to use the function we wrote earlier. I'm going to take the text and check if it's equal to Greg. This is the text that's going to come to that button. If it is, that will run. And if it's not, this will happen. So let's try that. And notice the different things that will occur. If I type Greg and click the button, unexpected lightning. Oh. I didn't have enough end brackets. This can become confusing real quick when you have if statements and other type of things in a function. Making sure you have the equal number of start and stop brackets can be a challenge. So if I type Greg, this happens. It says, "Hi, Greg." If I type someone else, it says, "Oh, it's someone else." And so when we click the button, the if statement checks is in text equal to Greg. When it was, that block of code ran. When that was false, it skipped down to where it says else, and this block of code ran. Does that help illustrate? So the if, it's a branching structure, and the if lets us branch off on what's going to happen based on a condition. So if one condition is met, this code runs. If another condition is met, that code runs. Does that help? Good. So that's an if statement. So it's a generic way of categorizing these things like the if statement is a conditional loop or conditional branching, because certain code is only running based on a condition being met or not being met. Another type of conditional loop is a switch statement. In Visual Basic, this is similar to a select statement. So with a switch statement, you have a series of specific possible answers. And so you go through, and based on those specific answers, that code runs. So we start out with switch in lowercase, and there's this statement. This is a variable. And I'll do an example of this too. That'll make this clear. So the variable, the switch statement is in between the brackets, like we see over and over. And within a switch statement, we have cases. So when the statement is the case value 1, this code will run up until the break keyword. So say the statement is state. If you wanted to say do something if the state entered is New York, you would say case New York and then run code. Case value 2 might be Pennsylvania, and then you could have different code run. So you have case, the value in parentheses, and a colon, not a semicolon. You write your code, and then the keyword in lowercase break, semicolon. And then the default colon runs if none of the cases are met. That's optional. So if your cases are New York, Pennsylvania, Ohio, and the person types Virginia, and you want to do something else, you use that in default. So here, I'm prompting the user to type in a country. And so then I start my switch statement and I give the switch statement the variable country. And then I'm going through, in this case, 4 specific cases. So as the switch statement is analyzed, let's say the country is Uruguay. This code runs. So in that case, if the person entered Uruguay, it will assign the value capital to Montevideo. If they entered Brazil, it will assign capital Brasilia, and so on. And default here will run if they enter anything other than those 4 values. It will set capital to not found. So can you kind of follow along how that works? So here, the person did type Uruguay, and then the alert capital came back with Montevideo. Because Uruguay was entered, this code ended up running, not the rest of it. So switch statement is useful when you want to branch in your code and do different things based on a set of possible values. You might have, countries are a good example. Your page might have to do something different. You might want to do something different depending on the citizenship of the person. And they enter, what country are you a citizen of? Are you United States, Canada, China? And then if you want to do something specific in those cases, a switch statement might suit your needs. So the next thing we'll talk about, another looping structure, is a for loop. That most programming languages, probably all programming languages, have something like a for loop. This will be, again, very similar to the for loop in C#. A for loop is used when a programmer wants a set of code to run over and over a set number of times. Either a set number of times or until a certain condition is met. For a for loop, it's actually more a set number of times. So I did write that here. A for loop allows a block of code to run a set number of times. Say you want a series of code that you've written to run 5 times. The for loop is how you would do that. Maybe you have a website with 5 map layers on it and you want to turn them all off. So you would loop through 5 times and say turn this map layer off, turn this map layer off, and go through it 5 times. So there's a very specific syntax for this that looks confusing at first, but we'll get through it. You start with a keyword for in lowercase, and then the rest of this is inside parentheses as I've drawn here. And to loop through 5 times, we have to define what's called an index variable. The index variable helps us manage how many times, if we want it to run 10 times, how many times through we are. So we define the index variable here, and I've called it I, and it starts at 0. I want to start at 0, and I'm going to call it I. So I said I equals 0. Unlike C#, you don't have to define the variable type. It's just I equals 0. And then semicolon. The next statement will be here, when does the loop end? So the loop is going, when the loop starts, I is 0. When do we want it to end? Or you could also say, when do we want this to keep running? And the second part defines that. So as long as I is less than 4, the loop should keep running. And then on the third line, I++, that means every time you go through the loop, add 1 to I. So this will run 4 times, 0, 1, 2, 3. And yes, I'll do a quick example of this. So I goes up by 1 every time the loop runs, and the loop will run as long as I is still is less than 4. So it'll go 0, 1, 2, 3. That will no longer be true, and the loop will finish. So we'll start out at 0. In this case, we'll say the loop will run as long as A remains less than 10. And again, the for loop is defined, its area is defined with the brackets. I'll also throw a concatenation in there. So we'll loop through, and every time the for loop will present this message box. And you'll see what happens with A. So A will go up by 1 every time, and it'll run as long as we stay below the 0 or the 10. So again, the code is executing repeatedly. We're up to 3, we're up to 4, and so on. The for loop is running, it's looping through, running that 9, and it stopped at 9. Because A, once we got to 10, 10 less than 10 is now false, and then the whole thing ended there. So again, we'll talk about some other types of looping structures now, but the key about 4 is that it runs a set number of times. In this case, 10 times. So as I just said, the for loop runs a set number of times. Sometimes you need a loop to run repeatedly, but you don't know when you start, you don't know how many times it's going to run necessarily. You may want code to keep running until someone clicks something or does something. So in that case, we have a while loop. So a while loop is, as I said, a type of loop that runs an indefinite number of times. You give the while loop a statement, and as long as that statement is true, this will run. So this is very important. I'm going to put it in red. Somewhere within this loop, there better be a situation where eventually that turns to false, or this will run forever. If statement doesn't end up eventually being false, there's nothing that will stop this other than going up, opening Task Manager, and killing your program. So there's no end. A while loop really will run indefinitely until statement becomes false. So make sure the code inside your while loop has the ability to cause the statement to eventually become false, or you have what we call an endless loop. And the only thing to stop an endless loop is shut the computer off or close the browser.
So you end up having all these boxes?
Yeah, something like that, or it just spins.
Exactly.
Or, yeah. You may have seen that happen on a website, and it's possible that the programmer didn't account for that when you see that happen, although a number of other things could cause it. So if I were start with x equals 0, and I'll say while x is less than, I don't know why I picked that number, while x is less than 1245, so we are up to so in this case, we don't know how many times it's going to run. But the key is I do have a situation where eventually, so I'm starting at 0. Every time I go through, I'm going to add 98 to x. And then it runs as long as it's less than 1245. So notice x is being added, 588, 686, so on. It got to 1245 and the while loop finished. So again, I keep mentioning this because it's a common mistake. Make sure that at some point the statement is false, or it'll never finish. I now have some examples, and we've seen some of these already, of commonly used operators in JavaScript. There's more of like a list of things that you'll see. Adding 1 to an integer, you saw that in the for loop a moment ago was plus plus. So f plus plus, just like we saw in the for loop, takes f and adds 1 to it. If f was 5, now it's 6. There is a minus minus, does you might guess the opposite. Takes an existing integer or numeric value and removes 1 from it. So if f was 10, f minus minus is 9. You access an object's members or properties with a dot. We've seen that already. So string dot length is a way to get at the length property of a string. So you've noticed that in all the examples before that we use a dot. This just kind of formalizes that for us on this table. Probably seen these before, but just like we've been doing since elementary school, a plus adds two numeric values together, and a minus would subtract them. That's pretty clear. It's something you may not have seen before. To reverse a Boolean, remember I mentioned a Boolean is a type of variable. It's either true or false. A Boolean variable can only be true or only be false. An exclamation point before the value reverses the Boolean. So in the simplest form, exclamation point true switches it to false. Multiplication in school, we used an X. But to multiply numbers in JavaScript, like in most codes, it's an asterisk. So 9 asterisk 7 is like 9 times 7. And we use the divide sign in element in school, but division in code is a /. So 30 /3, assuming all of these assume these are number variables. 30/3 obviously would then be 10. You can, I have done this, I've needed remainders in numbers. You can get a remainder with the percent that's the keyword. So 7% 2 returns 1. Because 7 divided by 2 gives you a remainder of 1. A Boolean expression, I mentioned that earlier, is either true or false. You use that type of variable. We'll see this when we get into the GIS examples. Use that type of variable where there's only one of two options, so something's either true or it's not. And greater than, less than, greater than, equal, or less than equal are just as you might imagine from math. No difference there. And again, I hit on these earlier, but to formalize this, if you're comparing two variables, we use a double. It's very easy to forget that. I've been doing this a while, and I forget to do that all the time. If you're comparing two variables, you need double equal sign, not just one. One equal sign said it's going to try and set the variable. An equality comparison is double equal sign. To see if two variables are not equal, it's exclamation point equal. And the last two, and I always forget, don't feel bad, I always have to look these up because I'll forget. Let's say your if statement, when I did the if examples, they were basic. But in an if statement, you can have a more complex logical question. So if I want to say, if I'm searching for, say, someone whose first name is Greg and was born in 1971. So you're searching for something where two things need to be true. In most programming language, it's pretty easy. You just put the word "and," not in JavaScript. In JavaScript, the keyword is two ampersands. And I had to look it up because I forget these two. I interchange them by mistake all the time. So here, what this reads as is if my name equals Greg. I actually left out, see, I told you I make that mistake. That should be double equal signs there on this slide. If my name equals Greg and year equals 1971 is how you would read that. And note that that should be double equal signs. If you're doing an OR, it's two vertical bars next to each other. So this reads if gender equals male or gender equals female. I don't know why they just can't do and or, but that's nothing I can do about that. So the and compare is the ampersand, and or is two vertical bars. Any questions so far? Similar to C#, JavaScript allows for something called a try-catch block. In a try-catch block, you use it if you're concerned about a group of code being problematic. This is code that, say, you're a little tentative about. You think it might cause problems and you want to account for that. You can put the code into a block called try. So if you put the code between these brackets using the try keyword, once again lowercase, you may be noticing all these methods are lowercase in JavaScript. JavaScript will try to run the code, hence the word try, but it will bail out if it doesn't work. What it'll let it do is bail out more gracefully. Sometimes, if a line of code doesn't work, it just blows up, does something really bad. So in a try block, the page will try to run the code. If it can't run, rather than just going to pot, the code in the catch block runs. So say, if you look at the lineage here, try, there's a line of code here, it works fine, no problem, it's just going to continue on. If, let's say this code is bad for some reason, if that line is bad, causes an error, this line will run within catch. So that lets you clean up. Maybe you were expecting here's a use case for this. You're expecting a number. The person types in their name instead of a number. Obviously, we can't go forward if there's calculations there. So then in the catch block, you could let a person know, you didn't type a number, and then use the return keyword to exit the program. Early for a break. I'll maybe go a little further. We're making good time tonight. We might dip into next week a little bit even. We'll start talking. We'll take a break in a few minutes. A JavaScript function, and this we talked about this a little bit already, but now we'll make it official. We're going to talk for a while about functions, and you already saw me develop a function in JavaScript, but here defines it a little bit more clearly for us. A function is a specific set of code that is designed to perform one specific task. As we saw when I did the example, a function does not run automatically just because it's in the script tag. It must be called from somewhere else, like when I called it from that button. Functions start with the keyword function in lowercase and are identified by name. So obviously, if you think about it, you can name the function whatever you want, but name it something that makes sense. If it converts kilometers to miles, call the function kilometers to miles. The flip side is that I've seen, if you go to some websites, they purposely don't make it. Like remember we were looking at JavaScript functions for this. Sometimes coders will do the opposite. They'll purposely not make it clear because they don't want someone to steal their code. It's called obfuscation or something like that, and there's code that you can actually do that. But in general, we'll say you should name it something that's easy to understand. And often a function is designed to do one thing and one thing only. And so you would name the function accordingly. So here I've called the function my function name. And I said a customary, though not required, is to start it with lowercase and then use uppercase letters for major words in the name. And then a function takes arguments. We'll have some more slides on this. So we can tell my function name to run, and you give it arguments. Like I gave it the name from the text box in the example from earlier tonight. That was what's called an argument. And then the function is defined as everything between the brackets. So I'm going to show that again quick. When I did this earlier, here's my function, and I called it from here. So the function only runs when it's called, and it's called with its name, and I passed an argument. This function takes one argument in text, and when I call it, that becomes in text. So I'm calling the function, passing that value, and that value becomes the variable in text inside the function. If you have more than one argument, Slice had more than one argument, you separate the arguments with commas. Like that. If, say, click me took 2 arguments. Also, reviewing what I just showed, but here are some strategies for calling a function from an HTML tag. I used the first one a few moments ago. I used an on-click event on a button. This is on an A tag. Same thing. On the on-click event, we call the function. You can just say my function name and pass the variable that way. You can also, in an A link tag in the href itself, call the function, not using onClick, but then you have to specify that you're calling a JavaScript function. And you do that with JavaScript : and then the function name. I'll focus on the first one because it's easier. Functions are also often called within other functions. It doesn't have to be from HTML. So here I have 2 functions called, the typo, that should be lowercase. I have function 1 and function 2. I can call function 2 from within function 1 by simply referring to it by name and passing the argument. So from within function 1, I just have func2, and they'll call it from there. You will have many cases where functions call each other like that. So I have a second function that's just going to alert a name. I'll just call it, and the autocomplete in Visual Studio will remember your function name. So notice what's happening here. I'm calling, kind of silly example, but it works. From within ClickMe, I'm just calling second function, passing it Greg again. So then that'll jump down to function, second function, and then the variable name will become Greg again. Oops, I didn't remove that. Hi, Greg, and there's the Greg again. So we went from function to function. I gotta take that out. Why would we use functions? There's many reasons. Organize your code. What you don't want is one program with 200 lines of code, 200,000 lines of code in it. Organize your code into blocks. Organizing it makes it easier to read, easier to port to another code. Eliminate duplication. If you're doing the same thing over and over in your code, which often you will, rather than writing the code over and over and over, put the thing that's repetitive into a function and just call the function repeatedly. You may want to reuse code with different parameters. Maybe you're converting metric to imperial units, but every time you're not using the exact same numbers. So have a, like I said, kilometers to miles function. You might use it a little differently every time by passing a different length. So reuse of code, eliminating duplication is the big message there with using functions. I think when we do Lab 1, you'll build a web calculator tool where the user can pick units and convert from imperial to metric units. And I think you'll see in that how functions are very handy. It's 8:15. Maybe this is a good time for a break. We'll take a short break. We'll come back and we talked about strings before. Next we'll talk about numbers.